Hi, welcome to the Rule of Acquisition number 15. This is the fourth edition of the Rules of Acquisition, and the fourth edition supersedes all previous versions. Okay, this is the 15th rule titled the Correlation Obscuration Trap. And the first rule, 15.0, is all that glitters is not gold. And I'll make meaning of what that means in a minute. I'm sure you've heard that expression before, but I'm going to put that expression into light of scientific thinking. Okay, now in this presentation, because of the new rules that we have to follow based on the new construct paper that was released, is that we have to make a declaration at the beginning of which units we're using. In this presentation, we're going to use legacy units. None of the new units here. We don't need them to make this document, whatever you want to call this. We don't need it for this. Okay, essentially, there exist false correlations in silence that obscure the true mechanisms of nature. And in the example, another example, is if it walks like a duck and quacks like a duck, then most people would assume that it is a duck. In other words, the properties of this object correlate to a duck, and therefore, most believe it must be a duck. And most of the time, we're probably correct. However, there may be cases where we are wrong, and the false correlation obscures the truth. And these false correlations take a long time for people to finally unwind them because they get so used to the false correlation that they can't imagine it ever being any other way. And so it's like built into their brain, and it's difficult to get rid of. Now let me use an example from history of a false correlation. Okay, weight was used for many eons as a representation of the quantity of stuff. Now, I'm using this symbol here to represent correlation. Now, that symbol means similar to, or a similar, and so it works. It actually works in this case, but it's not really a correlation operator. It is, but we're going to use it as a correlation operator. And so we're saying is because weight correlates to quantity, and it does, therefore, people believe that weight equals quantity. But then they noticed that weight changed at different altitudes. Now, this is a note about the footprint here. One of my science paradigms says that, we are going to develop theories and scientific theories, and they're going to be true and valid for all that we know. But as our scientific theories lead to better technology where our footprint can expand, and our footprint is how deep we can go in the ocean, how far we can go into space, how fast we can travel, how sensitive we can measure things, all of our abilities increase with new technology. And then that's when we usually run into the counterexamples in science. Okay, so we need our footprint to expand, because when we develop theories, we're going to make sure they work with everything we know, but we have to be open to the fact that as we expand our technology, we might encounter counterexamples. And sometimes those counterexamples may take 1,000 years of footprint expansion before we run into them, which was the case of Archimedes' principle. I'm not going to get into that right now. But luckily, when scientists noticed that this weight stopped correlating at different altitudes, luckily for us, relativity and quantum mechanics had not been invented, because in these sciences, they have trained people that mass and energy can be exchanged, and therefore matter can pop in and out of existence. And that probably would have been used to explain this instead of the proper rationalized event that occurred. Okay, so this is an example of correlation obscuration, where two different properties of matter, which would be weight and quantity, were so tightly correlated that we don't only ever see one construct. And I'm giving this the title, the amalgamation obscuration. Now, there's two things that are glued together so tightly we don't consider them as two things, weight and quantity. At a long time, if you went back in time and said, oh, well, weight doesn't necessarily equal quantity, people would have looked at you cross-eyed, like, what are you talking about? If I have two of something, it's going to weigh twice as much, and how can you say that weight and quantity aren't correlated? Okay, and this is only one variation. There are other variations where there is more than just properties of matter to be considered. And in other words, It could be other things, not just like weight or quantity. It could be some other property or some other construct of nature. And so we're going to use the term construct. And the other problem, which I just alluded to before, is the period that an obscuration can endure can be almost limitless in time. Because, like I said, with Archimedes' principle, it took over 2,000 years from the development of Archimedes' principle until ship technology allowed ships to go fast enough that the decorrelation between the mass of the water displaced and the buoyancy of the ship did no longer correlate. Okay, then they had to come up with something new. So there's no statute of limitations when we can hit the counterexamples to what we've known in the past. Okay, so how did we do this? How did we fix the correlation between weight and mass, or quantity? They didn't call it mass, and they called it quantity. Well, scientists invented the concept of mass, okay, and with the unit the kilogram to become the construct to represent the quantity of stuff, and force in newtons to represent the weight of stuff. Now, force was probably invented prior to this, but this is where they said, well, the weight of something correlates to its force, yada, 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 and that's old story. Okay, but there's a problem, because presently mass is also used as the inertia of stuff. So the quantity of stuff and the inertia of stuff is so tightly correlated that in equations such as this, we see, F equals ma going all the way back to Newton. And this means mass, quantity of stuff, but quantity of stuff here in this equation is representing the inertia of stuff. So here we also have another very tight correlation that still has not been decorrelated, but there are telltales that scientists completely missed. So again, if the correlation between the quantity of stuff and the inertia of stuff, the scientists can't see the distinction, and so this is the equation they go on. This is the relationship. If inertia is so tightly correlated to quantity, then inertia equals quantity, and that's how it's presently used. That's how it's presently used. Okay, Einstein himself made the distinction, but failed to take it to its logical conclusion. In other words, Einstein came up with a logical reason why these should not be correlated, but he didn't follow it through. And he indirectly did this in what's called Einstein's principle of equivalence, where if you have a person in a spaceship and that spaceship is being accelerated through space at 9.8 meters per second squared, he will not be able to tell the difference between that spaceship just sitting on the Earth. To him, he's being affected by his inertia, but he doesn't see it any differently than weight. To him, it feels like that's his weight acting on the bottom of the ship. Okay, so inertia is the illusion of weight when you're being accelerated in space, and weight is a force of gravity pulling you against the Earth. And the construct of inertia and weight, Einstein said, are essentially equivalent. Now, if you've been following Ethereal Mechanics, we basically show you they're the same thing. They're electromagnetic induction, but that's not really a story for now. And so here's the correlation paradox with this, because here Einstein says that inertia and weight are essentially equivalent, or they correlate very well. Okay, and in regular science, they say quantity and inertia correlate extremely well. But we already found out from history that quantity and weight do not correlate. So you either have to break this correlation or you have to break this correlation. So which correlation is the one so one of them has to go. You cannot defeat this logic. You cannot defeat this logic. Okay, in other words, if we don't resolve this, so in other words, either this correlation has to be broken or this correlation has to be broken, because if you don't, then you have a paradox in science, and that's not acceptable. So what is the resolution? Well, there has been a tell that when particles accelerated at very high velocities, scientists see their mass increasing. So they say mass. What they really mean to say is their inertia is increasing. Because when you say something's mass is increasing, you're saying that particles are popping into existence. So if you got this blob of matter that you're accelerating and you're saying its mass increases, are you saying particles are popping out? Where do they pop out? Do they pop out in the leading edge as it's traveling or the reverse edge? And so it's ambiguous. You can't say that you have just particles popping into existence. And then when it slows down, well, who decides which particles have to pop back out of existence? It requires too much. It's too extreme. You cannot explain things like that. It's better to say that the inertia of the object is changing, a state of its matter, which is just the same thing as saying its weight is changing when its altitude changes. And that is the proper decorrelation. Okay, again, I just talked about this. Scientists love energy and mass correlation, where again they love energy and mass popping in and into and out of existence in exchange for energy. In ethereal mechanics, we show you this is wrong. Quantity of matter doesn't change. It's just this ends up becoming your inertia when you look at the other video, the construct video. And all that's happening here is you're exchanging between one state of matter and another state of matter. Okay, the quantity of matter doesn't change, but its internal state changes. Just like moving money from your banking account, from your savings account to your checking account. Okay, no new money is being created. You're just moving it from one account to the other. And that's the same thing that's happening here. And this solves all the paradoxes that science presently has. And it means that inertia is mutable. Okay, because this is no longer mass, this is inertia, which we're calling by the letter B for burliness, heaviness. So if inertia is mutable, stick that into your can't go faster than the speed of light pipe and smoke it. Okay, so we have to break this correlation here. And now we have decorrelated quantity from inertia and weight. And it's interesting because the decorrelation of inertia is related to speed, which is related to kinetic energy. The decorrelation of weight is distance, well, height above the earth, distance, whatever, and that's related to potential energy. So you can almost see that we have kind of resolved the E equals mc squared because our decorrelations involve a change in state of energy. Okay, so that means these are both energy exchanging for inertia. And I'm going to show that inertia and weight are the same thing. And so if you followed ethereal mechanics, we show that the phenomenon of inertia and the phenomenon of weight, what Einstein says is equivalent, in ethereal mechanics we say it's exactly equal to induction, electromagnetic induction. You can look at the foundation series where we derive a model of matter all the way to this point. Now it's using new induction, not Faraday's law. Faraday's law is an incomplete description of induction. Now, in ethereal mechanics, we also show that all of these constructs here are two-body phenomenon, which means, and I'm going to show you an example with kinetic energy, potential energy in a moment, which means they're inextricably linked to matter and its various states. And we're going to dive deeper into this in a moment. For the moment, let's just lock down something. So we had three separate properties of an object that were inseparable to human thinking until recently, where quantity, weight, and inertia were all pretty much an amalgamation that we're hiding that they're different properties of matter, different facets of matter. Okay, and so now we're going to call this an amalgamation obscuration, where you had so many things glued together that you couldn't tell they were separate things. And this is decorrelated things, allowing us to see things in new light. And what other false correlations in history? Well, Archimedes' principle, where buoyancy was equal to the weight of the water displaced. That's a correlation that got decorrelated when ship technology allowed us to go fast enough through the water that we saw this phenomenon called hogging, which means it's not related. It's the weight of the water. It was a correlation, but it's not the true thing of buoyancy. It's like a gauge. It's something you can use to represent how much buoyancy you're going to get, but it's not the true mechanism of buoyancy. And also, The sun was considered a burning ball of anthracite. Why was that? Well, back when they came up with that theory, that's all physicists know. The only thing they knew that created heat and light was fire. So obviously, if all you know is fire that creates heat and light, then obviously the sun must be heat and light. And we're doing the same thing today. We're saying, oh, we know fusion and fission, so therefore the sun must be that. Now I'm showing you the sun is something far more grand than that, and it's a lot more, and it's not one way. See, nature likes to recycle. Fusion is a one-way process. Nature doesn't practice one-way processes. Nature recycles. We're not going to talk about that. Those are in my older videos, if you want to go through and watch my older videos. But it will also be put out since Ethereal Mechanics is on the downhill run, and we're starting to lock things down and produce papers on things that we're very sure about. You're going to see that again in a more detailed method with models and all that other stuff. Okay, so now we're going to dive deeper on what we talked about before. Okay, the information you're about to see is in the Ethereal Mechanics Constructs paper. And right now that's only for first-class patrons until made public July 4th, 2021. Okay, so this part here, and when I talked about this in the other video, I said we're going to discuss it in another video because I can put more detail on it. This is that video. So let's take a look at the construct of energy, something that has bothered me for a long time. Okay, and what I'm going to do in this little diversion here is I'm going to argue that the joule is a correlation that obscures something more fundamental. And I'm going to use an analogy to show that what we are calling energy is only a representation of something much more fundamental. And I'm going to use the example of the automobile. And this is the prop I used in one of my early videos. This is the family truckster from Family Vacation. I made a drawing of it, and I'm going to reuse the drawing. So in an automobile, you have a gas gauge and a fuel tank. The height of the fuel in the tank correlates to the quantity of energy in the tank. Energy in the tank. Okay, this height correlates to an angular displacement of their fuel gauge needle. So now you also have another correlation. Angle correlates to the energy in the tank. So what if you lived in a universe where you had no knowledge of anything outside the passenger compartment of the car? No knowledge of the gas, what gas is, no knowledge that there's such a thing as a gas tank in your automobile, how the engine works, or even how combustion works. All you know is what you see on the dashboard. Therefore, your whole body of scientific development would quantify energy and work in terms of angular displacement because you know nothing else. Angle, because in your world, because of your limited knowledge of your universe, angle correlates to energy, and therefore angle equals energy. That is a correlation obscuration. And we're going to call this a gauge obscuration in a moment. So let's go back into history a little bit. The development of kinetic energy was controversial because the theory proposed by Gottfried Leibniz said that kinetic energy is proportional to velocity squared. And that was contradictory to what Newton and Descartes thought it should be, which should be momentum, which is proportional to velocity. Later on, they were able to correlate everything and show that it's complementary to momentum. Okay, and that's what I just showed. And so basically, we have adopted a construct that correlates to observable work. Let me explain what that means. We are tool makers. We make tools from matter. And all of our tools, therefore, our understanding of energy is limited to observing what happens to matter. Matter is like our fuel gauge. Okay? And this is why our definition of energy contains matter. And they're using mass here to represent matter. So in other words, again, if all you had was a hammer, then everything begins to look like nails. Because that's all we know. That's all we have. We're using our tools, and we're correlating what looks like energy and work to the state of our tools, whether those states be velocity or height. Height. Okay, but there's another problem. All of the definitions are relative. So observer, in other words, this velocity is relative. So what one observer sees as the kinetic energy of this moving mass is not the same kinetic energy that another observer sees. And so we do not have a solid definition of energy that's observer independent. That's a problem. Now, I think relativity has tried to fix this. I'm going to show you there's a much, much better way to fix this than what relativity has come up with. Okay, again, the potential energy of something relative to light. And here's the other thing. These are both two body. If you only have one body in the universe, you don't have kinetic energy or potential energy. That's something that we can't get around with this. This is not the most fundamental description of energy. This is just energy as related by our tools. And it's relative, and it's matter-centric. So what we can say is, as an excited particle of matter can emit energy into free space, like emission of light or heat, which can then couple to another particle. This energy exists in the space between matter. Therefore, there must exist a definition of energy that is matter agnostic. That is the solution that would make the definition of energy the same to all observers in all reference frames, by coming up with an agnostic version of matter. And we have that in Ethereal Mechanics. It's in our earlier papers if you know where to look for it. But we're going to improve the definition going forward, so just wait for the new stuff to come out. So with regard to energy, we only have gauges. Our tools are merely gauges that represent the true underlying construct of energy. Just as a fuel gauge is a representation of the energy in the tank. And that's why we're calling this a gauge obscuration. Okay, and this is what bothered me for a while, because I could never get the units of energy to reconcile going forward, and that's because they are not the proper units of fundamental energy. And now that has opened the rabbit hole for us to go and develop the fundamental units of energy, which I'm very close to. But again, we'll talk about that in a little bit. So the legacy energy models do not allow us to see the true nature and mechanism of energy any more than the fuel gauge explains how combustion works. Okay, and again, this is a more fundamental form of energy. It's going to be a future release in the Ethereum Mechanics series, and the reason why is because I'm not quite done with it yet. I have another correlation obscuration that needs to that's in my way that I need to obliterate. Okay, so I'm not holding it back because, I'm trying to be, whatever. I'm holding it back because I'm not sure. Let's just say it that way. Until I get past this other obscuration, that will delineate what the proper fundamental units of energy should be. Okay, so again, what we have talked about is what we're going to call a gauge obscuration. Okay, and this is a case where we're using something to represent something more fundamental because we are not aware of this yet. And we have examples in the past where for luminance we used candle power, or for energy we used horsepower, which were later reconciled to watts and joules and all that stuff, and this was reconciled to watts per square meter. But again, they were useful gauges to quantify luminance and energy before we came up with a more fundamental thing. But because we have this more fundamental thing does not mean it's the most fundamental. It is just another in a series of gauges. So now we have to apply reciprocal thinking. Rule of acquisition 29 requires us to apply reciprocal thinking. Okay, so the reciprocal thinking starts off by restating the present example. If two or more separate constructs are so tightly correlated they appear to be the same construct, then reciprocally there could exist two separate constructs that have similar behaviors that are fundamentally the same. And this is rule of acquisition 22, the common behavior tell. So it's nice when I was going to try to condense this into one, but the correlation obscuration and the common behavior tell are actually better left separate instead of trying to combine them into one and make them confusing. So I'm leaving them separate. And so here we go. Rule of acquisition 15, we were saying that quantity was obscuring the concept of inertia and weight until we decorrelated them. Okay, and then rule of acquisition is basically saying since inertia and weight, there should only be one of these here, sorry, that was a cut and paste error, are essentially tightly correlated. In fact, I'm going to show you they are in fact equal, and that they are equal to electromagnetic induction. We're using equal signs here. That shows that you can have two separate constructs because of their tightly correlated behavior might actually be the result of one underlying force, and that is the stuff that we talked about in Rule of Acquisition 22. Now, I tried finding the old video for this. This Rule of Acquisition 22 was actually folded into the EMV series, which is okay. We need to reproduce this anyway to put the more detail that we learned in the Rule of Acquisition 15 that can enhance the Rule of Acquisition 22. So it's going to be re-released anyway with new information. Okay, so there's the wrap-up. Rule of Acquisition. Now, I'm not quite happy with all this, but I can't waste too much time on it. If we come up with a better set of these sayings or whatever, we'll improve it going forward like we always do with the Rules of Acquisition. Because I don't have that much time to spend polishing these. And anyway, but the Rule of Acquisition 15, the title is the Correlation Obscuration Trap, and it is a reciprocal of Rules of Acquisition 22, the Common Behavior Tell. And rule number 15.0, all that glitters is not gold. 15.1, correlations prove nothing. I'm sure you've heard that before, as correlations are not causality. It works out to be the same thing. False correlations where we have a causality that is not true. So I could probably even add that as part of this. I haven't figured that out. Anyway, 15.8, look for amalgams of constructs for potential decorrelation. And 15.3, so this would be the amalgamation obscuration. And 15.2, fundamental constructs can be obscured by false correlations. This is a gauge, and there's an example in the inertia in constructs video. Thank you for your time. I'm sorry, this video, I'm not as happy with this video as I wanted it to be, but I can't spend time on it because I got so much work to do in Ethereal Mechanics that I just need to get these out of my way so I can focus on Ethereal Mechanics. And so I apologize. This is probably not the best produced video in the world, but it gets the point across and it sets up the foundation for going forward, and that's the most important part of this. It may not be very entertaining, but there you have it. Anyway, thank you.